Hi guys, Mrs. Rhodes here, back at you. Oh, that's good. The buzzing is really going to help. Let's retry this. Okay, hopefully there won't be too many more of those buzzing noises on here. So what we're going to do first is define independent variable. The independent variable is going to be our cause. Okay? It is what is going to make the difference in our experiment. The way I like to think about it is what is different between the control group and experimental group. So I'm going to cheat and go down here to use Reddy's experiment as an example. We have jars. We have the meat inside the jars. When Reddy set this up, what did he make different between this experiment? And the answer would be the coverings. Okay? So that covering would be our independent variable. Next is dependent variable. That would be the effect. Remember, the dependent variable depends on the independent variable. Okay? And I like to remember this by what we are going to measure at the end. So what was Reddy looking for? What did he think this would contribute or cause to happen differently in the experiment? And that would be the maggots. Okay? So those maggots are the dependent variable. Okay? The control group, that is just going to be the group that does not get the independent variable. So here this would be the control group. I'm going to go to number 4, define a constant in an experiment. That would be what we keep the same between groups. Okay. Next, number 5, how many variables should you test in an experiment? So let's look at Reddy's again. What if we put a covering on it and this in the freezer and this opening and we leave this out at room temperature? Then we'd be testing 2 different variables, and that is not a very good controlled experiment, and our results aren't really going to tell us anything. So the answer for number 5 is going to be 1. We are only testing one thing at a time. And if you remember, we talked about the rat experiment where she gave them caffeine and also set them up in different cages. She was testing 2 different variables, and that was bad. All right, number 7. I forgot for this one, we want to think about those constants. So constants examples would be maybe the jars, the meat, the location, the temperature, things like that. There's a lot we could say for those constants. Okay, on to sample size. What is sample size? That's going to be the number of things tested in each group. So if you had 20 mice in this cage and 20 mice in this cage, this one gets caffeine, this one doesn't. Our sample size would be 20 because there's 20 mice in each group. And why is this important? The larger the sample size, the more confident we can be in our results. Okay? This we are going to talk together as a class. The next thing I wanted to go through in this video were just these quick definitions. So, biotic means living or once alive. Abiotic means never alive, like a rock. Heterotrophs are going to be like animals and fungi. They have to eat other things to get their energy. Autotrophs would be like plants or certain protists like algae that are going to do photosynthesis and make their energy from the sun. And we know extremophiles, a lot of those are in the domain Archaea, and they like extreme environments like super hot, super cold, or super salty. Okay? And